Good morning. Welcome back to the Asteroid Initiative Idea Synthesis Workshop. We're coming to you live from the Lunar and Planetary Institute in Houston, Texas. We're broadcasting on NASA TV. For those of you in the room and those of you online, we'd like to encourage you to continue the conversation using the hashtag NASA Asteroid. And right now, it's my pleasure to introduce you to Ellen Ochoa. She's the Center Director from NASA's Johnson Space Center in Houston.
Thank you. I wanted to take just a moment to talk to you as we start this final session. I had the opportunity to welcome you to the workshop. Of course, that was back in September. But now we finally gotten to conclude more than 30 hours of synthesis, including hundreds of people both here at the Lunar Planetary Institute and also those of us who are joining the session online. We've heard from colleagues in academia, industry, from international space agencies, and of course from throughout the NASA, as well as individuals and citizen scientists from around the world. So the results of this workshop are really going to help us as we move forward in planning the Asteroid Initiative, both the mission that we're talking about as well as the Asteroid Grand Challenge. So without further ado, I know we're excited to hear the findings, and we'll go on with the rest of our program. Thank you.
Next up, we will hear from Lindley Johnson. He's from the Planetary Science Division at NASA headquarters, and he will share some of the findings from the observation session that we actually held back on September 30th. Lindley?
Okay, thanks. Yeah, we had to dust off all of our notes from back in September when we, end of September when we did our work. But first, I'd like to acknowledge a couple of folks that helped me out a lot. I had actually two co-chairs. I need that much help. But I'd like to thank Paul Abel from here at Johnson and Paul Chodas from JPL. I refer to them as Paul A and Paul C to keep it straight. So. As far as the purpose of the observation session, I'd like to just refer back to the text that was in the request for information on what we were looking at in the observation session, in that we are looking for any means to augment and accelerate our capabilities for ground-based and space-based for detection of near-Earth objects, including the smaller-sized one. Of course, our near-Earth object observation program is really set up to find asteroids and comets that might be hazardous to the Earth. But in that work, we're also able to detect these small objects when they come closer to the Earth. So we're also looking for the small ones that might be retrievable for the asteroid redirect mission, and those capabilities that help us better determine their orbits, where they're going in the future, and also characterize their shape, size, spin, and all those other parameters that we need to know were we to either need to collect one of these and bring it into lunar orbit, or to take some kind of deflection operation against them if they were hazardous to impact in the Earth. So we had quite a response to the RFI. 90 responses were received, and a team which included both Pauls and a few other folks were evaluated those responses to try to sort them out using the criteria that all the other teams used. Scored those, each of those criteria 1 to 3 for each proposal, or each response, which would make a perfect score of being a 12 or a perfect idea. But one of the things we also use in our evaluation that's very important in support of the redirect mission is we need to be able to see some kind of return and collection of data within 3 years for detection or characterization. But we had many very good responses. You see the scores there. 29 of them, I would say, were rated very highly. 44 in the medium range, and 17 that maybe not quite so applicable to what we were looking for. It's always what you get in these things. You get responses from folks that have been involved in the business, really know their stuff, or really done their homework and know what they're doing. Then you get responses from folks that think they've got something there that could be really applicable, and most of the time, there's a kernel there that can be developed. And then you always have people that have a hammer looking for a nail, so you just have to sort through those things. So we had quite a few things that were good that we would talk about. We only had about 15, or a time for about 15 presentations here at the workshop. So we had to figure out how to get all those good presentations in there. We insisted that we have 18, although one of them dropped out. But I first want to, one of the ways we got through all the good responses, though, is a good number of the responses, 14 in fact, are from folks that we know well. We work with them already on the NEO program. They have projects that are part of the NEO program. And so those were things that we really didn't need to hear from them at this workshop. The purpose of the workshop was, in our opinion anyway, is to hear from sectors, individuals that had not talked to us before, or worked with us before. So anyway, these 14 highly rated responses are from folks that we work with, and I just wanted to acknowledge that we're either already working with you, or you have a proposal into us, so we know what you want to do. So these are all folks we know and love. So don't, just because we didn't talk about your response at this workshop doesn't mean it isn't good work. In fact, as you see, the number one there at the top, reactivating the WISE spacecraft for NEO hunting, we're already doing that. So we've already started work down this list. There's some others in here that are either on board for the NEO program, or will be in the future probably. So getting into what was actually presented at the workshop here, presentations that were made, our responses kind of broke down into four areas. Those that were about small ground-based telescopes, working with amateurs, 1 meter or smaller class telescopes in most cases. And then we had responses that were more centered upon software solutions, different types of algorithms or capabilities that could be brought to bear for the problem. Some of these things in the software area, they were interesting ideas. We could see maybe where they were applicable to maybe some of the other areas. Not necessarily to observations, though, and I know some of these also presented in some of the other sessions. So those are the first two areas. The areas were applications of radar or LADAR, laser capabilities for characterizing of asteroids. And then there were a few responses that centered around space-based capabilities, small sats, CubeSats, that could be either used in a precursor mission to characterize an asteroid, or during the retrieval mission used in support of the retrieval operations. So that was the nature of the responses. Here are some things that you could call our findings that we had in our discussions of the responses we had come out of them. First of all, international participation. Although we can't directly fund foreign entities with the program, they can be subcontracts to a U.S. entity, U.S. prime contact. But what we can do for the foreign participants is certainly encourage their governments and support organizations to become a part of the overall International Asteroid Warning Network. And I can certainly do that through the work of the United Nations Committee on Peaceful Uses of Outer Space and its NEO working group, and bring the proposals that we think are worthwhile for their countries to pursue to their attention. And we saw some very good presentations from several international participants in the workshop. New Zealand, Australia, and the Ukraine particularly are of interest. Then we saw 2 or 3 presentations that talked about improving the engagement for amateur astronomers to get into the work and help us out. But these amateurs need some encouragement and support to be able to do that. Work to learn all the intricacies of astrometric and photometric observations, learn those skills. So some kind of perhaps online program or a program that can be used to set up curricula in high schools or colleges to train budding astronomers in these capabilities. Then a good idea was assistance with how do you get the right hardware and software to be able to do worthwhile observations. Working with the telescope manufacturing companies and the CCD cameras, you know, there's a vast market out there right now for these kinds of things, but how do you know what's the right hardware and software to get to be able to do this? So work on a kit package that amateur astronomers can use to become part of the activity. And then how do you interface with the Minor Planet Center and with the professional astronomical community to get your data into them and have it worthwhile and become a part of the overall assessment work that goes on. So we think that's an area that we should really work on, and some valuable ideas there from our responses. Well, then there was a section, several responses that talked about repurposing assets that the United States has, either on the DoD side or with the professional astronomical community, National Science Foundation, assets that have become fallen out of the funding for their current programs that might be repurposed for the NEO effort. And so there are several ideas there that we would like to pursue. And then one last area I'd like to talk about is a few ideas about partnerships with some of the entrepreneurial organizations for a space-based precursor mission, a small spacecraft that might be a secondary on some of their launch, to go out and characterize a potential target, or spacecraft that are going to ride along with the robotic retrieval spacecraft and assist in its operations, either collecting a small asteroid or collecting a mass off of a larger asteroid, helping to characterize the overall target an asteroid and finding the right boulder to extract, or how do you really approach the small asteroid correctly. So any economical ideas that can be done there, or cost sharing partnerships with these organizations, I think we ought to look into. And so lastly, I just want to say, as far as the NEOO program, it's clear our way forward, because this program has an annual solicitation for proposals for funding. It's part of our Science Mission Directorate's annual omnibus solicitation, research opportunities in space and earth sciences. That solicitation, national research announcement, comes out every February. It's all done online. You can see where those announcements are on that website there, that's from the Inspires site. NEO observations is Appendix C9 of the solicitation. The notices of intent to propose are due in April every year, and the proposals are due in early June. We then take all those proposals, we have a peer review of them that we organize and conduct late summer every year. And then when funding becomes available in the next fiscal year, we award those proposals that we think are the most worthy of the funding that's available. That's it. Thank you.
Thank you, Lindley. Now I'd like to introduce Jim Reuter. He is the Senior Executive for Technical Integration at Marshall Space Flight Center, and he will discuss the findings from the asteroid redirection session, and that one was also held September 30th.
All right, well, just like Lindley, we had to dust off our notes, and I could read almost half of what I took back then and make some sense of it. We had an excellent session, I thought. Steve Sanford, over to the left side of the room, was our co-chair, and Heather Hinkle was our moderator, and did a great job keeping us straight and provided technical expertise. The purpose for our session was three things. First, to look at concepts for robotic spacecraft systems to enable rendezvous and proximity operations with an asteroid and redirection of an asteroid into translunar space. We had a special emphasis on integrated sensing systems to support asteroid rendezvous, proximity operations, characterization, and capture. And we were to look at refinements of the asteroid redirect mission concept and opportunities for dual-use technology development. So we had a very broad scope that focuses on the redirect mission itself. In terms of selecting the RFIs for presentation, we received 75 responses, and as Lindley said, we had a very tough time narrowing it down. We ended up selecting 16 responses for discussion at the workshop. We consolidated those just from the timing standpoint into 3 presentations, plus we ended up having 1 walk-on at the end of a paper that was going to be another session that really fit better with ours. And so we appreciated those couple of folks where there was a related papers that we asked them to kind of consolidate into 1 briefing, and that worked fairly well for us. We looked for a mixture of industry, government, international, and university. The governments were all NASA papers. And we targeted responses for discussion that represented, something we thought was an interesting or new idea, system variations or added details to what we had, and generally focused just by the nature of the timing on higher TRL technologies. So it wasn't that there wasn't a lot of other good responses, but those are the ones we want to get a cross-section from the community and looking at those kind of criteria. I won't read this chart, but this is the session as we laid it out, and with the addition at the end. All but 2 of the presenters were face-to-face. In a general sense, and we'll talk about organization of the topics that we covered in the next few charts, but in a general sense, we had John Brophy came and gave really an overview of the reference configuration and the background to get there from the Keck Institute studies that really started this in 2011. Then we had a series of papers that were really on the system solutions side, followed by a series of papers that were focused on the sensing systems, and then followed by some alternate concepts. So that was the general layout of the briefings. So when we regrouped at the end and looked back, we kind of categorized our topics that we discussed into these 6 areas, and we'll talk about a little bit more about each one of these areas in the coming charts. But vehicle systems, sensing systems and algorithms, mission enhancements, extensibility, alternate mission scenarios and concept of operations, and different business strategies. So you can see it spanned a pretty broad waterfront. I'm glad I'm inside. So under the vehicle systems, the types of things we talked about were a lot of discussion on the key technology readiness for the solar arrays, the thrusters, power processing units, etc. really, and we generally did not have as many papers that focused on Hall thruster that we had bring forward, because generally that was considered the technology of choice for the mission. But we did have some discussion on lower TRL in that area. There was a fair amount of discussion on adaptations of existing spacecraft buses, of how we could take advantage of those that are available on the commercial side. And there was a good deal of discussion on the balance between technology development for improving the mission versus using low-risk, mature technologies. You know, do you follow an on-ramp or off-ramp philosophy? The general preference in our discussions were, we'll push some technology up front, otherwise it will never on-ramp. But have a strategy for, but do that where the significant benefits are seen, and have a strategy if you need to back away. There was a good deal of discussion on the importance of being able to verify and validate the system on the ground, and a need for flexibility in the design to accommodate surprises as they come up. And generally the key risk development areas that were identified was the asteroid characterization part, rendezvous and capture system, solar arrays, high power thrusters, power processing units, the xenon tanks, and dust and volatiles. In terms of the sensing systems, I can't say too many S's in a row, and algorithms, there's a wide range of sensor technologies that were discussed for various mission requirements, from the characterization phase, rendezvous, proximity operations, and capture. We looked at things like targeting size, the target size, shape, range, tumble dynamics, shape modeling, closed-loop control with an uncooperative target, considerations for surface and subsurface characterization, especially depending on the option that you chose, and even crater detection and tracking, and structural strength of the asteroid. And candidate sensor technologies included those listed there. We discussed also, there were discussions also on the integration of those systems and algorithm development, and a lot of discussion on the adaptation from heritage systems. I won't read them all, but there was a wide variety of systems that are potentially applicable to use in this mission. Other key topics that we discussed in the mission enhancements areas, there was discussions along the lines of adding robotic manipulators, enhancing the characterization of the asteroid, using it for potential for dissimilar capture techniques, since that's going to be one of the critical areas, and considering whether we want to have dissimilar approaches. And it was generally considered, although not necessarily, an enabler for a pick up a rock scenario, that kind of. CubeSat class observation and sensor spacecraft, as in Lindley's session, were talked here. Contact excursion probes, surface samplers. There was some discussion on the potential for science, and whether we could take advantage of the transition time from the asteroid to cislunar space for some of this. In terms of extensibility, there was a fair amount of discussion on the broader solar electric propulsion applicability, something that we would develop here, has uses in commercial, especially if we look at our requirements and performance standards as being something that's of benefit elsewhere. Satellite servicing missions has a similarity in needs. Potential for commercial applications such as AIISW and fuel for satellites. Potential for reuse as a cargo tug for translunar assets after we've completed our mission. Planetary defense, asteroid deflection demonstration. Of course, there was a whole session on that, but we had some discussion of that. Whether it applied to space debris removal. And potential for the value of the remaining material, a commercial follow-on after the crewed mission. And finally, on topics discussed, the alternate mission scenarios and concepts of operations area. We started, as I said, with a review of the options that started from Keck Institute. There was discussions on the benefits of obtaining multiple samples from a rubble pile type asteroid as opposed to a single sample. Precursors, as talked in Lindley's as well, there's a considerable amount of input on the importance of that and understanding where you're visiting before you get there. A lot of discussion on considering a campaign rather than a one-off visit, and potential for potentially visiting more than one asteroid in this. Many moons was a topic that was unique, that was talked about, and that is there is a population of asteroids that are temporarily captured in cislunar space, And one of them, there's theoretically several of these. One has been detected, so there was some concept of saying, well, maybe you should consider an alternate destination. In terms of a concept of operations change, a consideration of whether you wanted to separate the transporter, which, the main bus, mothership SEP vehicle, and the capture vehicles, and whether there'd be some benefits to doing that. And finally, we had a category on different business strategies, whether we could apply a COTS-like model for commercial partnership engagement, possibility of industry partnership on the precursor side, and whether we can, and the leveraging of existing industry assets, have NASA focus on the innovation areas, allow industry to do what they do well. And then finally, the findings relative to this mission that we came out with, summarizing all those topics. First was to establish a concise set of mission objectives and figures of merit. There's all these opportunities, but what is really important? And that should include, though, extensibility and commercialization considerations, weighing the cost, though, against mission objectives, with a highlighting that launch vehicles are always a concern and something that you have to pay attention to up front. Understand how much asteroid mass is enough. Is it a quality versus quantity discussion? Do you really need to go to, how much mass do you really need to successfully accomplish this mission? And a strong emphasis from the room on the top FOM need to be sustainability, not just a single mission for this to go forward. Another finding was perform an assessment on the various mission concept options, including weighing technology on-ramp versus off-ramp, as we talked, and mission enhancement options. Focus risk reduction activities consistent with the concept and leverage our inputs, including addressing the commercial utility of those technology development areas, and then the tech transfer implications of doing so. Consider follow-on studies for sensor technologies. There was a lot of discussion of a lot of different, a range of instruments that might be available, and we should follow on with addressing the potential for integrated sensing system that's able to support all mission phases and broader NASA exploration needs. There was discussion on improving the coordination with the small body science community and address how we deal with business case partnership opportunities. So that's all. That was the summary from our briefing, and thank you.
Thank you, Jim. Next, we have Dan Masnek. He's a Senior Space Systems Engineer at Langley Research Center. Dan is going to talk to us about the findings from the asteroid deflection demonstration session.
Okay, thank you, Wendy. Good morning. So first of all, let me acknowledge my session co-chairs, Pat Troutman, also from Langley, actually had to leave prematurely this week due to some family constraints, and Paul Abel helped fill in for Pat here locally, so kudos to Paul. Thank you, sir, for helping out. Also, Pedro Lopez and Jonathan Bowie were our moderators during the session yesterday afternoon, and then our follow-up discussion this morning. So next slide, please. So, oh, I can look here. That's good. That's twisted my head. So this is straight out of the RFI. Again, the purpose of this session was to look at the deflection of the trajectory of an asteroid using a robotic redirection vehicle that would be effective against objects large enough to do significant damage at the Earth's surface should they impact. So that's the basis for the RFI response, and of course that doesn't necessarily mean that you have to go to an object that big to perform that demonstration. So we have the reference approach and the alternate approach, and both of those are considered here. Just a brief note there. I'm going to check my time. The brief note on the demonstrations, some examples, but not limited to. Slow push trajectory modification, specifically another technique called the gravity tractor using gravitational attraction was called out. Instrumentation, deployable, and other techniques for planetary defense. For example, transponders are doing something ancillary. But these are, again, not limited to, and you'll see from the topics that there was quite a variety of discussion. Next, please. So I didn't put the numbers up here, but we had 92 submittals, and 13 of those were selected for presentation. We were somewhat time constrained, so we try to pick a representative set in these particular areas is kind of what came out, and we had a couple presentations in some of the areas, which was good to have in terms of some reinforcement of ideas, and then potentially some differences that were noteworthy. The first area was repositioning a small asteroid or a portion of an asteroid to subsequently be used for an impact for a large incoming asteroid. So this kind of cosmic billiards approach, that theme was in a couple of the presentations, many of the RFI responses. Using the engine thrust to push an asteroid while using opposing thrust to hold the relative position, commonly known as the ion beam deflection or ion beam shepherding. So that was one area we had a couple presentations on. Low-cost kinetic impactor, which has been a key element applicable to mitigation approaches for the Grand Challenge, but probably only applicable at the end of the Pick Up a Rock mission for the ARM or the ARRM. The enhanced gravity tractoring with local mass augmentation. So the gravity tractor has been out there for some while now, and one of the issues is because the gravitational attraction is so small, it takes an extended period of time to provide enough change in the orbit of an asteroid. This aspect of using mass that you pick up at the asteroid is kind of a new idea that kind of changes how effective that approach is. Using solar energy for vaporizing asteroid material, and using swarms of small satellites attached to an asteroid to despin or redirect it. Those are the six main areas that were kind of unique demonstration approaches. Area 7 was proposals that spanned all the areas of the mission envelope that support asteroid deflection. So that could include devices that are brought, different takes on the spacecraft system itself, etc. So next, please. So I am not going to put this up here. I didn't just put the agenda back up. I tried to capture a little bit of a description for each of them. So there's 4 sheets in here that give a snapshot more than just the title of what was talked about in each of the sessions. I'm not going to read through them, but I'll summarize. These first 3 were from larger corporations that had spacecraft systems that could be used for the mission, and with some different technologies or demonstrations of mechanisms, particularly like for the Northrop Grumman, the use of the astromesh concept to create an array was talked about. So next, please. There was a couple, these 3 presentations focused, and the 4th one on the next page, focused on the gravity tractoring, the enhanced gravity tractoring, and also the use of Jeff Landis at Glenn Research looking at using the returned asteroid for this kinetic impact defense against a large one. The next, again, the last one here is, whoops, go back to 3, please, was again using the mass augmented gravity tractor. The ion beam deflection, John Brophy presented that concept. And the multiple attached vehicles was presented as well. And finally, a couple of the other ideas on the 4th slide here is utilization of space materials for deflection, so using the in-situ resources, solar collector option, and then the ISIS mission that's being proposed for the OSIRIS-REx mission as a sister mission to Bennu. Was discussed by Steve Chesley. And then finally, Honeybee Robotics, they gave presentations in a lot of the sessions, but many of the devices, the space mechanisms, could support planetary defense efforts or be tested. So next. So the key topics that were discussed here, and I'll briefly go through these, and I've got some of the findings and then some what I call nuggets at the end that if we have time I can just at least flash up and people can read over. They basically, there were 3 classes of demonstrations presented. Ones that, with little or no additional cost, could be implemented. And by that I mean basically using the assets that we have available through the mission already. And I'll talk a little bit more about that. There's deflection demos with additional costs that would be, for example, the kinetic impactor, solar collector, microsatellites, et cetera. Now, how much that incremental cost is would need to be determined, but we think that there's a delta cost that would need to be considered. And then there was, again, the demonstration of the devices that are applicable across a wide variety of defense approaches, but are not necessarily demos based on the ARM concept. There was a discussion about the potential to combine approaches and techniques to provide a more effective or comprehensive demonstration. I think that's a good avenue to think about and pursue. And in order to implement effective deflection demonstrations, we really need to do the analysis and the assessment to see what is the time required to develop the technologies, to make sure that there's no impact, or we understand the impact to the overall ARM mission budget and schedule. The enhanced gravity tractor, this mass augmentation, the ion beam deflection, and a post-mission kinetic impactor using the ARV, either with or without the return mass, because in both of the approaches right now that we're looking at, we have the ability to separate the returned material from the SEP, and as for both contingency and repurposing at end of life. They were all considered as deserving further study from the ARRM mission, the robotic mission. Next, please. There was discussion about demonstrating adequate navigation accuracy for kinetic impact or deflection technique against particularly smaller near-Earth asteroids. When we start going down to tens of meters in size, it becomes a much more difficult problem. The terminal phase of maneuvering for a kinetic impactor, and particularly what we call this mass-augmented kinetic impactor, can be a difficult final navigation problem in terms of actually having the control authority of the spacecraft in order to do the maneuvers. Having an observer spacecraft at the target can help with that problem, but that's something that has not been looked at, so there was a discussion about the difficulty, complexity of that. There was a good amount of discussion on making sure that we binned the demos into the ARM or the Grand Challenge bucket. The focus of the RFI was on the ARV, but of course the whole Asteroid initiative includes the Grand Challenge, and there may be applicable demonstration techniques that don't work well with the ARM robotic mission. Demos don't need a large deflection to prove their effectiveness. With an observing spacecraft, something on the order of 1/10 of a millimeter per second can be discerned. So again, this is a demonstration of an approach, not necessarily to prove that you can move at the actual amount that would be required for an actual planetary defense mission. And planetary defense demonstrations can be performed on very small near-Earth asteroids, but they're more relevant to the larger ones, as was the call in the RFI. A couple other ideas that was discussed was using the ESPA-based ESPA ring for creating a SEP module, use of the launch vehicle upper stage for impactor mass, similar to the L-Cross mission, and solar sails for passive deflection. So those were just other ideas that kind of came up during the discussion we wanted to capture. Next, please. Finally, deflection approaches that utilize direct push by need further assessment to determine their effectiveness. There were some members of the session that think that they may not have gotten their fair shake. Or there are complications with contacting the surface and particularly pushing in the right direction effectively, but we captured that thought as well. So next, and how many more minutes do I have? A couple minutes? Okay. Findings relevant to the reference to the asteroid redirect mission as opposed to the grand challenges was that, again, the enhanced gravity tractor, the ion beam deflection, and the post-mission kinetic impactor were all considered as innovative, valid concept with potential benefits. A comparison of the cost, relative effectiveness, risks, and applicability to small near-Earth asteroids and large near-Earth asteroids needs to be assessed in a consistent manner. All the presentations had different assumptions, and there needs to be kind of an apples-to-apples comparison to see how well they fit in. Other demonstrations that don't affect the ARRV, such as a kinetic impactor, where you'd have the vehicle observing at for example, at a large target NEA, are recommended if budget permits. One concept there is it provides a direct comparison of the slow push techniques if we were to do that. Next. Whoops. Demonstrations of nuclear planetary defense capability is not compatible with the ARRM from a budget, schedule standpoint and other, regulatory conditions or issues. However, some of the hardware and operations needed could be tested, and there was some heated discussion, some passionate discussion about all that. Robotic spacecraft mechanisms in support of planetary defense. And again, I've just listed some here that were examples from the Honeybee robotics. Surface samplers, pneumatic sampling and excavation, snare system, or a self-opposing multi-mode anchor could be used directly or evaluated during the robotic mission if additional costs could be shared. So again, it's a cost issue and a complexity in how it affects schedule. So next. So from findings relevant to Grand Challenge, many of the demonstrations, such as a kinetic impactor, solar collector, or use of in situ materials for mass driver or propulsion, could be important to addressing the wider Grand Challenge. And the session participants felt it was important to capture that and make sure that, again, we're looking at the near term here and with respect to how it can be accommodated on the ARRM, but they should be giving some amount of analysis and detail to see how they could potentially be accommodated if cost sharing or funding can be provided. So that's it on the findings. The next couple of slides, if I just have a minute, are just some nuggets, as I call them, that we pulled out. So next, please. There's just two slides here. And these were just some of the suggestions that came out, or the ideas during the discussion, during the presentations. One of them was for the Northrop Grumman concept with the astromast, was to actually use the solar arrays to provide high bandwidth communication as well, and just off point, because you've got plenty of power when you're at the target, thereby getting higher bandwidth communications. Space Systems Arousal concept of having SEP thrusters on arms so that some of the thrusters can be rotated to perform the ion beam deflection demonstration more effectively. In industry, those mechanisms are currently at TRL 9. Right now on the redirects, the ARV, we just have a fixed set of ion thrusters in one direction. And with that technique, you want to have opposing thrusters so you can maintain your position. A separable spacecraft concept to provide better operations near a large near-Earth asteroid, as well as situational awareness, is an idea that's been discussed before, and it was discussed here again. The possible use of the Earth-Moon L4, L5 points as a long-term storage location for that mass-augmented kinetic impactor using the ARV, whether for an impact demo or actually planetary defense. And then the last slide is a couple more here. Tim McElrath at JPL had the suggestion of leaving the mass close to the near-Earth asteroid for the pick up a boulder approach or pick up a rock using the enhanced gravity tractor either on a short tether or boom. That minimizes the distance to increase the effectiveness but keeps the spacecraft further away. Could potentially reduce operational risk. John Brophy, per Andy Thomas's suggestion of using the ion beam deflection to slow down the spin of a small near-Earth asteroid to improve the capture dynamics, looks like it might be something that could be feasible. The use of CubeSats to provide a low-cost transponder to test tracking for future monitoring of hazardous near-Earth asteroids. That's a possibility. The additional costs of DSN tracking and time and the whole thing would need to be included as well. And then finally, the AIISW kinetic impactor could be a very low-cost approach for demonstration on the asteroid redirect mission. And of course, that is only applicable to the larger target since we're bringing back the entire asteroid with the find a small one. So that's it in a nutshell, and did pretty close here. Thank you very much.
Thanks, Dan. First off, I know we've all heard the thunder going on, so I wanted to let folks online know that NASA TV is experiencing a little bit of technical difficulties, so the broadcast might have a few interruptions. Next up, we have Andre Sylvester, and Andre's from the Robotics and Simulation Division at NASA's Johnson Space Center, and he will share findings from the asteroid capture systems.
Good morning. Thanks for the opportunity. I was the session chair for the Asteroid Capture Systems session, and I'd like to acknowledge Jason Reboyne, my colleague. He was originally scheduled to run the session, but had an illness that limited his opportunity to participate. So he and I worked on the charts together, and also wanted to acknowledge Pedro Lopez, who was our moderator. So to give you a perspective, our focus was a little bit narrower than some of the other groups. If you look back at the big picture that was outlined at the beginning of the workshop in September, our session was focused on the redirect portion, and then even more specifically the capture phase. If you look at the little spiral there, you can see we're just looking at a very select element of the overall system and mission activity. And so from the reference design, what we wanted to do was look at responses from the RFI related to the capture mechanism. And so to give you even the narrower focus in the reference flight system concept, that little sliver at the top is the mass and volume allocation for the capture system. So we're trying to do a lot with a little bit of space there. And you can see one of the reference concepts there outlined down below. There's a lot of elements of inflatable and deployable structures associated with the baseline concept. So as we looked at the RFI submissions, we ranked them against the factors that were provided, relevance to the objectives. Does it have the potential for a major impact to the success? Is our technology mature enough that it can be incorporated, as several speakers talked about, focusing on higher level TRL, as a way to have rapid insertion, and then affordability. So we had 2 reviewers read each RFI, use the same rating factors that several of the presenters described, and then the top rating ones were included. So we had 38 submissions. We selected 9 for presentation, and then an additional presentation was added to our session, which had some relevance but wasn't part of our initial pool for review. So what I wanted to do here was just give you a quick visual impression on the different concepts we presented. I've got the sessions included in the backup of the presentation. So if you go from top left to right, the first element was an anchoring system from Honeybee Robotics. We had a robotic linkage system from MDA. Top right was ATK deployable structure. If you go to the second row, left item was a concept from Langley Research Center. The middle one was, I think, the Boeing company had some concepts leveraging on some of their expertise. The one next to that was the Airborne Systems deployable structure concept. On the far right is the Northrop Grumman Astromesh concept applied to this problem statement. And then we had 2 tether presentations, one on the bottom left from Tethers Unlimited, and then the bottom element from Marshall Space Flight Center. So we had a wide range of different ideas on how to go out and engage our target asteroid and engage in the capture phase of the redirect mission. So I want to talk a little bit about our findings. So of all the ideas presented, what seemed to be the biggest challenge, and this was brought out early in the presentations, was as you're approaching this object, it's almost guaranteed to have some rotation rate, some tumbling going on. And so how do we use these systems to be able to reduce or eliminate that, as much as possible, because we need to be able to control the integrated spacecraft stack. So of all the concepts that were presented, it appeared that the tether concepts were the most innovative approach, because one thing they brought to the table was the ability to reduce or eliminate the rotation and nutation without actually having to engage a larger spacecraft system. So it gave us a more cooperative target. Now the inflatable concepts had a lot of merit, and you saw a couple of them up on the presentation there. We've got a lot of experience on those in ground system performance. We've only had a few on-orbit demonstrations. We've had one on the shuttle and a couple in some other areas. So there's some opportunities there for, I think, technology maturation. And then the deployable structures and robotics concepts actually have the potential for greater control authority, because you've got potentially manipulatable grabbing capability. And we just need some more discussion on the mass requirements to make those systems be as effective as they can be. So in that technology development line. I think we determined that the flight tether systems, if they could be tested in LEO prior to the asteroid missions, I think that would give us some additional confidence. And I shared with some presenters after the meetings about some of our opportunities for using the ISS utilization capability as maybe a way to explore some of those capabilities. Also, the attaching of the tether to the asteroid, we need, I think, some further definition, and there's some opportunities there. On the inflatable systems maturity, I think if we could do some flight tests in LEO, and again, the station environment, I think, might be a good place. And then our deployable structures, we can, in robotics, can do some implementation options to help us understand mass reduction capability. So in relevant to the mission, where we might have some linkages, some cross-fertilization between those ideas, the tether-based free flyer combined with an inflatable system, I think would give you a win-win in terms of reducing the spin rate and then capturing and securing the asteroid. So you get both major objectives. And then anchoring system concepts maybe could enhance the tether-based free flyers. So our recommendations for further studies or next steps is to look at some trade studies between the deployable and inflatable beam ideas with respect to the reference concept. We've got some metrics there, packaging, ability to handle the detumble dynamics. Again, that was mentioned as a key element in the session. And then one of the ideas that came out was if we're going to use the main spacecraft for the detumble, how can we keep whatever mechanism we use from potentially damaging the comm arrays or the antennas? And so 2 additional studies to look at ways to precondition or detumble the asteroid prior to the capture, in essence making that target more cooperative. And tethers might be a good aspect there. And then also look at retractable arrays as a potential. I know in the solar array arena we're trying to make our arrays as robust as possible, and adding another mechanism to retract might create some complications. But it was something that was discussed during the session, so we felt we'd like to make mention of that. And then this was the session agendas. So we had broad participation from industry, government, internationals. So it was a very good session. Thank you very much.
Thank you, Andre. Next up, we'll hear from Steve Stitch. Steve is our Deputy Director of Engineering at NASA's Johnson Space Center in Houston, and he will tell us the findings from the Cruise Systems for Asteroid Exploration session.
Thanks, Wendy. I'll start off by sort of summarizing the session at a high level. I thought we had a very good dialogue. We at the last hour, trying to sort of understand a little bit about what we had done on the NASA team, and then some of the ideas in industry, and talking back and forth about the mission. You know, we really do see this as the first mission in a step of exploration missions in cislunar space that is aligned with the global exploration roadmap that we talked about that at the session. And I think we had a real good understanding of how this mission sort of fits in the overall framework. Our RFI topic was to look at lightweight, low volume systems that could help with extravehicular activity as the crews get the sample from the asteroid. Also looking at robotic concepts and translation and EVA tools. That was the main topic area that we asked for in the RFI. We had 22 proposals, and those came from industry, academia, and different NASA centers. We had a team of 3 individuals look through those proposals and work through them and try to understand which ones would be best to bring forward. So we graded those on the merit for the mission. And when I say mission, I really am talking about the initial mission, where we have 2 crew using EVA from Orion. Extensibility toward the next mission. How does the concept proposed in the paper feed forward toward the next mission, whether it be missions in the lunar vicinity or deep space or eventually toward Mars? What's the design maturity of the concept? And in many of the proposals that we saw, actual hardware prototypes had been built, or in some cases systems have flown in space. So in general, I would say the proposals were very, very mature. And then application toward the mission. How does it really fit into kind of what we're doing on an initial mission? So we consolidated those recommendations into 13 proposals we brought forward. And as again I said, it represents industry, NASA, international, and academia. We then divided our discussions into really 3 different areas. One is extensibility for exploration, and proposals along those lines came from Boeing, Lockheed, MDA, and Oceaneering Space Systems. We had the next topic area we divided into anchoring techniques for how to anchor on the asteroid. Those came from Honeybee, the Jet Propulsion Laboratory from the Goddard Space Flight Center, and the University of Maryland. And then probably the area that we had the most proposals in was the translation and EVA tools area. And again, we had proposals from the Jet Propulsion Lab, Honeybee Robotics, MDA, University of Maryland, Kennedy Space Center, ATK, Space Systems Loral, and then the Goddard Space Flight Center. So we had a good number of proposals in each of the areas. What I'll sort of do is talk through each of the concepts a little bit. In picture format, I probably don't have as many words as the other presenters do. One of the areas that we really thought was very germane to extensibility was the Boeing proposal, which you'll see in the upper left. And this is a node-based module, an exploration module that would enhance extended stay durations in the cislunar vicinity to either do more work on the asteroid or other operations in cislunar space. It's kind of based on a heritage node design that we've used successfully on the International Space Station. It could be provided by the U.S., by an international partner. So there's a lot of potential to go forward with that kind of concept. And this is very similar to some of the concepts that we've studied within NASA. We also, at the bottom left, had an innovative concept from Lockheed Martin. Their concept was to leverage Orion, which is a very important, perfect spacecraft for the initial mission when we're trying to execute it very affordably with only 2 launches, the robotic spacecraft and Orion. They have a concept where on the top of the Orion vehicle, they would have a pantry area to store additional consumables, additional provisions, and maybe even use that as an airlock. And so that was a very interesting concept that we talked about. And then, so those really were from the near term. And again, you can see at the upper right a potential international partner module that uses kind of the Russian docking node that we could then use in cislunar space to do more exploration of the asteroid or other operations in terms of science, telerobotics on the lunar vicinity or other things. And there were other numerous robotic concepts, like at the bottom. This was from Space Systems Loral, kind of a concept that has a robotic vehicle that then could interact with the asteroid and a longer arm that could position a crew member to interact with the asteroid. We saw those kind of concepts as a little further out, maybe a little down the road, not germane to the first mission since it's affordable, but very good things that would lead forward to exploration as well. So I thought we had a very good discussion on extensibility. And then the next phase was anchoring techniques. And we had a lot of innovative ideas relative to anchoring that kind of extend the breadth of asteroid operations. We had a lot of good discussion on the different types of asteroids in terms of the solid material asteroids or ones that are more like rubble piles and how these would work. This microspline technology on the bottom right from the Jet Propulsion Lab is very interesting. The industry also has some similar ideas on how to do those. So we talked a lot about anchoring techniques. Our concept for the initial mission is more of a platform, a boom platform to work on, not actually tying to the asteroid, but of course for exploration, these are very good techniques. And then here was a very innovative robot that anchors itself to a rocky asteroid from the Jet Propulsion Lab that we discussed. And as we evolve our concepts, we'll take this work forward and in the Neutral Buoyancy Lab where we've been doing testing on better ways to anchor. Then we'll move on to a translation and EVA tools. We had a number of good discussion topics along these areas, talking about how we would interact with the asteroid. There were several good proposals on a microspline drill, which is sort of shown in this animation, how an astronaut might attach a pistol grip tool to that drill and bore into a solid asteroid and extract a sample. We had several different proposals discussing that technique. We talked a lot about how to anchor and how we would extract samples from the different kinds of asteroids. And you might need different tool sets depending on whether it was a solid asteroid or more of a rubble pile type asteroid. There might be different techniques, but there was a good broad range of ideas that we discussed. And then we talked, and the third topic area was really translation and EVA tools. And on the upper right, you see a session in the neutral buoyancy lab of where we're trying to understand how to translate in the suit. We discussed a lot about worksite preparation and how to anchor. There were several good techniques. One from the University of Maryland on using some kind of cables to anchor. The spline technique for a solid rocky type asteroid was a very good technique. At the lower right-hand part of the screen, we also talked about the dust problem that Apollo had with the dust getting on the suit. And the Kennedy Space Center had a very unique approach of attaching some electrodes and using a certain coating on the material. That's something we're going to talk about a little bit more. Is that something we can then use to maybe keep the dust off the suit? But we do realize contamination will be a very challenging issue depending on the kind of asteroid. And then we had a lot of really good ideas on tools from ATK, from Goddard, the robotic satellite servicing, from Oceaneering Space Systems, and some of those are shown here. You can see in the middle of the screen on the upper part of the slide, that's the robotic refueling tool that's on orbit today being used on space station. On the upper left is some toolkits that ATK has built. On the lower right is this microspline drill, which we really think was a very innovative technique. The big problem with drilling into an asteroid is creating that reaction force so that the crew member can then push the drill bit into the material, and that was a very innovative technique. At the lower left are different ways of maybe taking a sample from an asteroid surface, getting the regolith or the dust material off the asteroid. And then for translation, we talked about, we really were very intrigued with this idea of the telescoping booms proposed by ATK and others to augment our EVA reach. We use a boom concept to position the crew member to take the samples. And we have limited reach with our current concept. This is an area that we really thought we'll look at in more detail. So we took all the inputs from the session and we looked really at the near-term mission, this first mission, and so we probably have more specific recommendations than maybe some of the other areas. The first one was we need to continue to explore this asteroid exploration module concept that Boeing talked about for the next step beyond the initial mission. We really think that's great for extended duration missions in cislunar space, and it does feed forward to Mars. We've looked at that module serving as an airlock on the NASA side. We've been, as a next step, if you're going to do more extensive EVAs with a more capable suit, then we would have that serve as an airlock. We thought the self-anchoring microspline drill as an EVA tool was something that we should go pursue to extract samples from a rocky type asteroid. We thought that was a very good concept, and we'll continue to see if we can fold that into our concept. The dust shield technology that the Kennedy Space Center discussed, that Rob Mueller had, is something that we would like to do some further testing here at JSC to understand how that might work on a real suit. I know they've done a lot of samples on flat surfaces, but is that a promising technology for an actual suit? I mentioned the telescoping booms. We thought that would really enhance our ability to reach broader areas of the asteroid and get maybe samples that the scientists may want. And then obviously there were a lot of great ideas on tools, and we'll feed those into our NBL runs as we work on those in FY14. And then a lot of the other robotic enhancements, we see those as future capabilities, and we'll continue to fold those into our exploration plan as we move forward. So that's a summary of our findings. I'll sort of show the agenda briefly and who participated. Again, I want to thank all the presenters. I know it's a big effort to put together the paper and travel to Houston to present, but I thought we had an excellent session, so thanks.
Thank you, Steve. Next up, we'll hear from Jason Kessler. Jason Kessler is the program executive for NASA's Asteroid Grand Challenge program. He will share findings from the partnerships and participatory engagement session.
Good morning, and thank you, Wendy. So, we had 3 sessions associated with this part of the RFI. What I'm mainly going to focus on this morning in the findings is the partnership and participatory engagement session, but we also had a session on crowdsourcing and citizen science, focused specifically on the Grand Challenge, as well as a next generation engagement session for the Grand Challenge as well. So the purpose of that of the partnership and participatory engagement session was really to develop a shared understanding of what that meant and how it might benefit both aspects of the Asteroid initiative. We're also anticipating a rich dialogue between not only the presenters, we had 12 in that session, but with community as well, and pulled in ideas from Twitter and the feeds. We were hoping to get some clear ideas for what implementation might actually look like. We had great ideas, but how would we actually move forward with those? Were there areas of overlap, opportunities that presenters didn't know about one another that might lead to benefits just by being in the room or seeing the presentations? And then finally pull out what the next steps or actions might be so that we were clear where we were going. For our selection process, we had 55 came in specifically for the section on partnerships and participatory engagement. We had a center-wide team review those proposals. We had at least 3 people look at each, so we had a wide set of eyeballs on those. And did a scale of 1 to 5 in each of these categories, pulling out those that ranked with 4 or 5 average to come and present. And so we had 12 in partnership and participatory engagement, we had 8 in crowdsourcing and citizen science, and we had 5 invited for next generation engagement, but 2 were unable to attend. And so we had a lot of people bring in a lot of great ideas, and as you'll see, we sparked a lot of good conversation. The agenda, I too, like Dan, pulled out some of the salient points from each of the presenters, and for those that weren't in the sessions, I hope you'll indulge me as I kind of pull out some of the nuggets from each of the presentations. We had Mike O'Hara representing Aerojet Rocketdyne, really strong presentation because of the experience that Aerojet Rocketdyne brings to this very topic. And you can see what participation means to them. Following Mike was Bo Naz from Goddard, talking about the Restore Satellite Servicing Mission model. One of the key takeaways there was the effective use of CRADA in association with a FAR contract, and how that was really working quite well for them. Great idea for us to consider in other forums. And then Charlie Chafer from Space Services Holdings followed, talking about the Sunjammer technology demonstration mission that they are partnered in. A really interesting business model that they were surprised got approved, and that NASA was willing to go as far as they've gotten with that. And that made up the first section within that session. We tried to group them as they were related in topics. We then transitioned into Chris Lewicki from Planetary Resources and talking about his ideas for potential data buys on asteroid information, and also really interested on excess capacity to get into solar orbit. So we think about low Earth orbit possibilities, but could there be considerations on helping folks get into a solar orbit as well? After Planetary Resources, we had Scott Sevchik, had an interesting concept for demo days and a public demo plan, and saw really two areas of most benefit from NASA with their endeavors, and that's really, number one, funding, and number two, visibility. After Scott was David Gump and Rick Tumlinson from Deep Space Industries. Very clear focus on a COTS model to enable industry engagement and identification of what's needed and letting industry go and execute on that. Closing out the second section of our session was Eric Mumm from Honeybee talking about their rich history of robotic tools and what that might mean in terms of a partnership effort for the mission. We then transitioned into a slightly different flavor. We had David Gustin from Arizona State University, a really broad-ranging submission that was made up of a number of people that contributed to it, and it was really, how does one get to this idea of governance that's based on a public policy conversation, a two-way conversation between the citizens and those that are making decisions on missions or policy. Following David was Margaret Race from the SETI Institute, bringing in a perspective on risk and how might we think about engaging in the conversation around risk. It's, I think, easy for us to focus on the risk of a mission and the risk of the technology, but what are the ramifications on broader society? And we have a rich history of looking at risk in terms of the disaster response community. So it was a nice area to pull out. After Margaret, Joe Lepore, representing Space Design Corporation, came up and was talking about their studies on solar radiation pressure and looking for some of the market drivers that would be beneficial in considering the exploration plan. Tony Freeman from JPL followed up with a comprehensive presentation on the effectiveness of programs and the history that NASA has of running a program and how beneficial that would be to the overall initiative to have a program actually formed around this effort. And then finally, Jean-Claude Piedboeuf from Canadian Space Agency did a great job of highlighting the activities that the Canadians are focused on, bringing the interest from Canada and some of the industrial expertise that they would have to apply towards the mission as the planning moves forward. So as you can see, it was a broad-ranging discussion. So the key topics that we discussed, unfortunately I don't have pretty pictures like Steve, but the ideas were great. We had great examples of successful partnership, which I think we can build upon. Ideas for financial incentives and other models that might be applied for both the mission and the grand challenge. It was useful to be in the room with smaller companies that were talking about some of the struggles they have. It's really easy, I think, to stay in our shoes and deal with the same people that we normally deal with in industry and not recognize the challenges and hurdles that others might face as they try to engage with us. And so as we really look to engage more broadly, it was just really helpful to hear that perspective. And some additional engagement activities of how we might talk about the mission, talk about the grand challenge, and bring people into that conversation. With a recognition that this RFI was a great start to pull ideas in and allow people a platform to share those ideas and be recognized for their work. So the findings that were relevant to the mission. I mentioned the CRADA example from Bo Naz. It'd be really useful to take a look at what they've been doing up at Goddard and to factor that into the thinking for the mission of how one might design effective contracting and industry engagement. It was also very clear that looking at the COTS and ILDD as models to pull industry in a way to support the mission would be a really valuable thing to consider as well. Also brought up were data buys, incentive prizes. Are there ways of structuring a type of information that was needed that we're looking for and let others go off and get that for us? Talking about the smaller business perspective, really understanding what motivates industry, whether it's large or small, understanding what their business model is really helpful if we can get there and have them as a part of the conversation, because that can ultimately help with mission design. And then specifically when thinking about the mining business, it was recognized that it's hard to do. And so are there ways that the mission planning can factor that thinking in so that we can look at this as a joint effort and recognize that there's a future beyond what we're just thinking ourselves? The other thing that was pretty loud and clear, and I think we've seen it in some of the other findings, was getting clear mission objectives, sticking to them, and making clear definition of who's doing what so that people can make their decisions and move out on that and be good partners because they know what part of the deal they're supposed to be holding up. When pushed in the audience, what's a single thing? What's maybe the most important thing that we could do? Doesn't have to require money, but what would be helpful to you? And it was simply stating that a Mars mission is going to require in-space resource utilization, and a recognition that to go to Mars, that's something that we're going to need, would be tremendously helpful to industry and startup companies looking to participate here. Another idea that was clear and came out was the development of, and I'm taking my Office of the Chief Technologist hat off in terms of roadmaps and focusing more on kind of specific technical roadmaps, because there was a lot of energy around this idea that as students, a lot of the people in the audience got turned on by having technologies or areas that they could focus, and they saw where that fit into an overall plan. They were able to fill that gap. They were able to build skills that then were going to be available either in the private sector or at NASA. And so if we can get real clear on the technology needs that we have, so that we can then open that up to industry and universities and say, here are the gaps, guys, that would be really helpful for them. The other thing that came through pretty clearly is just the speed at which industry and government move is different. And so thinking that we're going to have an industry day in the spring, for some industry, that's just too far away. And so don't feel like we have to make it perfect and it has to be the biggest, best thing. Just keep the conversation going and keep people involved, because they have capital that's getting burned and don't necessarily have the luxury to wait around for us to get things perfectly. So just to keep the conversation moving. And then a more specific finding, when we think about making access easier for people to participate, came around just a paperwork issue. The idea and interest of participating in an IAC proposal, 3-page proposal, and from their perspective, right or wrong, I can't assess that at the moment, but there was the perception that to do a 3-page proposal required over 150 pages of reading and multiple websites to log into, and that's just in a lot of ways too big of a barrier for a 3-page proposal that might or might not get selected. And so if we can make things easier, potentially have the proposal accepted and then that paperwork gets done. Not clear what the answer is, but the message was loud and clear that you guys can be hard to work with. And so if you can make it easier on us, and this is kind of that one-time thing, because if you've gone through that process, you're already in the system, so it's easier for folks. So those were the main findings from the session on the mission. The main findings from that session on the Grand Challenge really came about thinking about risk differently, and there was a point made about the 2004 tsunami, that there were an incredible number of lessons learned because of that tragedy, and I fear we're probably going to relearn some of those with the typhoon in the Philippines as well, but that there is a community that studies risk and the way we respond and the way we communicate and the way that we prepare, and so that's an area that we need to factor in Grand Challenge planning and thinking. Consider more forums for engaging the public, but doing so in a two-way conversation. One of the points a little lower down is there was a sense that in an auditorium setting, it was hard to feel like we could get into a rich conversation. It felt a little bit like transmission, and so if we could design it in such a way that there was easier conversation potential, that would be welcomed. I talked about the demo days, but the idea of having an overall plan where smaller technology demos are being done already, but is there a way of pulling those together in a coherent plan so that disparate ideas that are being worked by others could come together in a way that they could then spin off of one another and spark new ideas? And so how to look at building public activities that enable multiple benefits. Another interesting one, very targeted, recognizing the power of NASA's social media and the ability to get the word out. Could we develop a process that partners could submit into the agency a request for a retweet, and there'd be a formal process for that, but that kind of power would be really helpful to somebody, assuming that the interests are aligned, and so that was a nice little nugget to take away. And so moving forward for the Grand Challenge, we anticipate holding a virtual seminar series starting most likely in February to continue the conversation, and then finally you see the URL there at the bottom. We got a wiki page started to gather ideas and had people in real time with both the partnership with the crowdsourcing citizen science as well as the next gen engagement sessions adding their ideas. And so that's the place that we're sending folks right now to send their ideas and continue the conversation, because we wanted to make sure that from the Grand Challenge perspective that when we leave here that this momentum isn't lost and that people's voices can still be heard. And so with that, I will close and thank everyone for their time.
Thank you, Jason. Actually, before we invite Michelle up to conclude the workshop, I'm told that we have a time for some questions. If anyone in the room has a question for one of the session leads. Anyone? Oh, one over here.
I just want to compliment the entire project, and it was great, especially just now watching Jason up there, having been in the room, watched the interaction that went on, and actually see in what he was showing up on the screen the fact that he listened. And because I remember the exact comments that people made, and they got captured, and they were listened, and they've been reflected back. And that's I think, pretty good to hear for everybody who showed up here. So I just wanted to make that comment.
Thank you. Anyone else? Okay, well, we'll invite Michelle Gates from NASA headquarters. She's from the Human Exploration and Operations Missions Directorate, and she will conclude the Asteroid Initiative workshop.
Hi, good morning, everyone. Well, we've certainly covered a lot of ground in this RFI and in our workshop. We started off looking for input in cross-cutting technical disciplines that cut across both the Grand Challenge and the redirect mission. Early in planning, I think we would all agree that we accomplished those goals. It was extremely interesting to see the session leads briefings today and the variety and breadth and depth of information that came forward. Many of the discussions and findings appear to be applicable to both the challenge of finding all asteroid threats and knowing what to do about them, as well as redirecting an asteroid to the lunar vicinity for exploration by astronauts and returning samples with astronauts in our Orion spacecraft. Several of the planning leads mentioned ideas that came in through the RFI process that they're already implementing. I think that's a good sign. And we've shared with you our process for including ideas into our current studies, as well as potential additional activities, and our plan for an industry day, which I now understand is potentially too late for some folks, so we'll go back and think about that. Thank you so much for the feedback. Just real quick, I took way too many notes to reiterate here, but we heard broadly conversations and topics of value in near-Earth object observations, the redirection of an asteroid, deflection demonstrations for asteroids larger than 100 meters, capture systems, which is both deep and broad on its own, crewed systems for asteroid exploration, and partnerships and participatory engagement. So we did cover a lot of ground. Chris Moore from NASA headquarters is actually going to be leading the final report documenting this workshop and the findings. He's planning a release late in January of that report. And we're also working on posting our presentations online. We're looking for releases from all of the presenters before we do that, and then we'll be doing that posting. And then real quick, we wanted to take the opportunity to honor and thank one of our colleagues who's been so instrumental in this process, Erin Mahoney. The Johnson Space Center has collaborated to provide you with this fine plaque in appreciation for your leadership in organizing these sets of activities, as complex and challenging as it has been. We thank you for your excellent support and leadership.
Thank you. Thank you very much.
And thanks to her whole team. And thank you all for your time and the session chairs, and we look forward to continuing to work with you all. And if you need anything or have any more thoughts, feel free to share. Anything else, Wendy? Thank you.
Thank you, Michelle. This concludes the Asteroid Initiative Ideas Synthesis Workshop. We encourage you to keep the conversation going, and we want to thank all of our presenters and everyone who joined us here in Houston and online across the globe. And like I said, keep the conversation going. Thanks.